Hello, everyone. My name is Michael Awaje, and today I will be covering the fates of lactate. Here's a brief overview of what I will be discussing. Basically, the major steps of the pathway lactate takes to be formed and how it's used throughout the body, how exercise intensity and training, how it affects our body and what we're able to do with our body, and the differences between lactate and lactic acid, its metabolic uses, as well as the consequences of lactate accumulating and that its effect on our ability to sustain exercise, as well as factors that influence exercise stopping. So let's get into it. Uh, First, we have glycolysis. In order to make ATP, generate energy for our body, we break down sugar. We break it down through glycolysis into pyruvate. And under normal conditions, when there's plenty of O2, that pyruvate will get turned into acetyl-CoA, go through the citric acid cycle, um, go through the electron chain, transport chain, excuse me, and we'll get all this ATP that way aerobically. But when it's anaerobic, when there's oxygen is scarce, uh, these pyruvates we get turned into lactate. So it's an anaerobic byproduct, and our body ships that lactate out of the muscles into the bloodstream to get taken to the liver. So that lactate goes into the liver and it's turned into pyruvate to get turned into new glucose. This process is called gluconeogenesis, new sugar creation. And this is what we use to send back to the muscles in order to fuel the muscle and provide it with energy. Glucose could also get turned into glycogen, the storage form of glucose. And yeah, it's a cyclical pattern of glucose turning into pyruvate, into lactate, back into pyruvate, back into glucose, back out into the muscle. So lactate is affected by exercise intensity. At moderate intensities, lactate is built up, but it disappears just as fast as it's produced. However, when we increase intensity and do high intensity exercise, we see a sizable increase in lactate production. Over time, as we train, our bodies are better able to handle it. Our mitochondria, our capillaries are able to meet this new demand in lactate and be able to further continue exercise. And a shift in lactate threshold and onset blood lactate accumulation is observed as well as we intensify our exercise. It's a graph showing what's happening as we increase oxygen consumption, increase exercise intensity. This is the point of lactate threshold, which is at 1 millimole. So this is where, okay, we're starting to pick up intensity. Lactate buildup is starting to build up. Lactate is starting to get built up. And at 4 millimoles, this is the point where we see the onset of blood lactate accumulation, and we see a dramatic increase in blood lactate. Now, you probably have heard lactic acid and lactate be used interchangeably in gyms and everyday conversation. And even though it is used interchangeably and they are related, they are different. They're different molecules. Lactic acid is formed when lactate uh, receives in hydrogen. It's an acid. Acids are acidic, so their pH, potential hydrogens, is affected by the number of hydrogens that's available. The more hydrogen, the more acidic, basically. And these two are not the same. These are two different, same but different. Lactate is the conjugate base of lactic acid. So related but not the same. And like I explained earlier, through the Cori cycle, uh, lactate is used, it's oxidized in order to turn it back into pyruvate to be used for fuel. It gets turned into new glucose, as well as it also signals to other muscles and tissues and sends responses due to exercise and oxygen availability. And it also enables continued ATP production because it's used as the fuel. And as we breathe, get oxygen back into our bodies, it triggers the ATP production. Now, lactate accumulation doesn't come without consequence. As we're building up all this free hydrogen within our body, our bodies aren't the best suited to work with in highly acidic environments. So this impairs our muscles' function, and this is what leads to that burning sensation that when you're lifting those weights and you're getting to that last rep. And so the metabolic byproducts lead to impaired muscle contractility and energy production and fatigue. So basically, the lactate is a very important and a part of our metabolism, of our use of getting energy in exercise training. We take it out of glycolysis. Pyruvate gets turned into lactate. Lactate gets shifted into the liver. It's turned back into new glucose that we use for fuel. Turned into glycogen that stores energy, raises the acidic environment of our bodies with exercise. And as we train, we're more adept at dealing with this buildup, but it still does affect us. And I hope that you all came across this video and learned something new and positive, and you think twice about using that lactate and lactic acid, because your boy Michael said so. Thank you for watching this video, and I hope you have a wonderful rest of your day. Thank you.